Math 96, section 10.2. Here we are dealing with some formulas that we normally use it in algebra. One formula is that if you have a radical and this is x is the base, n is exponent or power, and m is root of a radical. You could always convert radical into exponential form. Means you go from radical to exponent. To do that, you have to write your base, and then you take this power divided by the root. So here, problem is a2, b2, the whole thing to power of 1/3. The whole thing to power of 1/3. I want to change that to radical. So that 3, which here is the m, see the denominator of the fraction is the root. You see how these two are close? So that 3 would be your root, and then you write a base, and the power is 1, which we don't need to put that 1 here, because if the whole thing is to power of 1, it doesn't make any difference. So here is another one. But in a case like this, there is a second formula that if you have more than one power, you always multiply. Let's say I have here x to power of 2 and the whole thing to power of 3. It's not x to power of 8. This is not correct. The reason is this: when you have x2 to power of 3, means you repeat x2 3 times. So, see, that means, look how many x's do you have? 6. So it would be x to power of 6. It means if you have more than one exponent, you always multiply the exponent. You always multiply the exponent. So in this problem, what I did, first I know that 81 is 3 to power of 4. X, the power of x, if you don't see any number, is 1. So when you take the whole thing and raise it to this power, it means you could take the exponent and multiply by exponent. 4 times 3 over 4, or 4 over 1 times 3 over 4. The power of x, if you don't see any number, is 1. 1 times 3 over 4, 1 times 3 over 4. 4 and 4 cancel. Then you end up having 3 to power of 3, x to power of 3, 4, which is 27x to power of 3, 4. Now we decide to just take this part and change it from exponent to root, or to radical. I'm sorry, to radical. From exponent to radical. If you want to go from exponent to radical, that's how you write it. And that 27 always stay there. So this is conversion of the exponent to radical 4. Conversion of exponent to radical 4. Here they want you to do backward. They want you to go from radical to exponent. When you don't see any notation for the radical, is always 2. If the root of radical is 2, we don't have to write 2. So if you don't see any number, it's always 2. And if you notice on your calculator for a square root, there is no indication of the root. So if you don't see any number, the root is always 2. I'll put it here so you could see it's 2. But if the root is not 2, it's 3 or 4, you always have to write. So what's the power of 19? 19, there is no power, so it's 1. So if I want to convert radical to exponent, that's how you do it. If you want to go from backward, if you want to go from radical to exponent, you write a base, in this case is 19. You take the n divided by m, n over n, n over n. So it would be 1 over 2. Same thing here. See, the whole thing is to power of 1, so it's 1 over 4. Now, Next, we introduce another formula, which is if you have a negative exponent, you have to take the negative exponent, change it to the positive exponent. See, negative exponent is meaningless. When I write here 2 to the power of 1, it's 2. 2 to the power of 2 is 2 times 2 is 4. 2 to the power of 3 is 2 times 2 times 2 is 8, and so on. But if you have 2 to the power of like -5, I cannot take 2 and multiply by itself by negative time. So in that case, you have to change the negative power to the positive. In order to do that, the formula said just write it as 1 over 2 to the power of 5. That's how to change a negative exponent to the positive one. You have to inverse this. So 2 to the power of -1 is 1 over 2 to the power of 5, or 1 over 32 is a very small number when it's a negative one. So in that case here, 27 to the power of -1/3, what we do first, we take the 27, write it as 3 to the power of 3, then you multiply the exponent, here, what we discuss here. So 3 times that is -1, and 3 over -1 is 1 over 3. Now, in a case like this, the only variable that has a negative power is this. So if you want to change the -5/2 to the positive, it has to be at the denominator. Okay, so let's say another example. Let me show you this. Let's say I have 3 to the power of -1 times 5 times 2 to the power of -1, and I have here, I don't know, 7 to the power of -1. Look at these examples. Since the power is negative for 3, if you want to change -1 to +1, you have to bring the 3 to the bottom. 5 doesn't have any exponent, so you just stay there. 2 to the power of -1. If you want to change the negative to the positive, you get to reverse it, means bring it here. 7 to the power of -1. If you want to change -1 to +1, you get to bring it up. Okay, so it would be what? 35 over 6. So anytime you have a negative exponent, and the negative exponent, if you want to change it to the positive, it has to be at the denominator. But the other ones are positive, they all stay. Because of negative exponent, I got to reverse the whole thing first to make it positive. Then you could also write 5x to the power of this to the power of that. And then you reverse it. You just say, you know what I have here? I have 1 divided by this fraction, right? 1 divided by these fractions. You know, and you understand that if you want to change division to multiplication, you get to inverse this. You do that. So then that's what you have. The next formula is if you are multiplying 2 terms and they both have the same base and different power, you write a base and add the power. Look here, 6 to the power of 3, 4 times 6 to the power of 3, 8. They both have the same base, which is 6. So you write that. But then you add these two. That's what the formula says. Like if I have 7 to the power of 2 times 7 to the power of 3, how would I multiply this? According to the formula, we ask you to write it as 7, 2 plus 3, 7 to the power of 5, right? But you could actually see 7 to the power of 2 means you expand it is that. 7 to the power of 3 is this. So what? We are multiplying 7 by itself 5 times. Okay? That's what this formula is. So you always add the power. What if you have ratio of 2 variables with the same base? Okay, so you have the multiplications, x to the power of n times x to the power of n, bases are equal. You have the same thing, but this is division. In the case of division, instead of adding, you're subtracting. And that's what you have here. So first, before I do these problems, I know that the exponent negative, I got to bring 8.2 to the denominator with 4/5. Minus 5/4. If I want to change negative 5/4 to the positive, you got to move it from denominator to the numerator. You got to do this first. And since they both have the same base, see, x, this and these two are equal, you write one base and you subtract the denominator. Since they both have the same base, you write one base and you subtract the denominator. And then these are example of multiplications. They both have the same base, you add. This one, you do multiplication first. See how you multiply the power first, and then you add. Okay, so that would be end of 10.2.